Okay, we're going to start inequalities. We have to know what it means to solve, but first thing, let's review the little symbols. Remember the symbols, the alligators or Pac-Man? Did you guys use Pac-Man? The big opening goes always towards the bigger number. This means less than. Yes. Not in this class. And then this is greater than. If you put a little line here, it really means less than or equal to. So there's two things. Okay, Marie, Josh, question? Yes? And this is greater than or equal to. So actually, there are three things that can happen between numbers. 2 could be less than 3, 2 could be equal to 3, or 2 could be greater than 3, and only one is going to be true. Which way is this? Less than. It's a way to compare numbers. This is the law of trichotomy. Put this on. Because it's not on, not recording much. There. Okay. I think I hear myself. Now, when you have the less than or equal to, we are going to make a closed circle. Otherwise, it will be an open circle. Okay, do you guys remember doing this?
Yes, I do.
Okay. Yeah, you probably have done it for actually quite a while. Just a way of comparing numbers, except we're going to do it algebraically. So the biggest problem that you guys are going to have is remembering whether or not to close the circle or leave it open. Here's one way I help you remember, is this has a little extra line, so there's a little more pencil mark there, so it's going to be closed. That helps. Now, before we even do this problem, we're going to write down what it means to solve. So we're going to do this a little differently than I've done before, that you've seen before. What does it mean to solve an equation? Jake, are you there with me? What do you mean? That's using the same word I'm trying to define. So if I say x plus 2 equals 5, and I tell you that x equals 2, have I solved that correctly? Yeah. Okay, I got a yes and I got a no. How do you know, Ted?
Because we know from experience that.
Experience? No.
Yeah, because we've experienced that a 2 and plus a 2 equals 4.
Okay, so what he's doing is he's putting it back in here. 2 plus 2 is not 5. He's looking to see, Nick, if this makes this sentence true. Well, if we know what solve means, we can solve just about anything. That means to find the numbers. I'm going to use the number symbol. That's the number symbol that make the sentence true. You need to write this down.
What do we do?
Yep. Let's see if I can do 2 words in 1 word, huh? That make the sentence true. So you know what? There's nothing wrong with guess and check.
Oh, okay.
Do you write it down, Paris? You got all that written down. Wow, she's good. So if I know that, then inequalities are so easy. If you write down what this means, it also helps. So, are we ready? Okay, fine. Some of you may know what to do with that.
What's that word after
True. Doesn't even look like an S. True. That looks like an E. There's the U. And that's an E. Okay, so I'm going to write in English what this sentence is saying, Elias. This is asking me to find all numbers. What? What word goes for this symbol?
3.
No, this symbol right here.
Oh.
Greater than.
Greater than. I'm trying to translate it into English. Okay, I want to find all the numbers bigger than 3. Okay, Jake? I want all numbers bigger than 3. Well, what's one number bigger than 3?
4.
Yes. 8. 4. 7. 99. Oh, my favorite number. How about pi? We have pi.
Oh yeah, actually
7.
that works.
Okay. Can I list them all?
Yeah.
No, I can't list them all. So instead of listing them all, I'll draw a picture to represent the answers that make that sentence true. So I'm going to label this as 3. And that's the boundary point. This is called a boundary point. Because that's where things are going to split. I'm either going to grab one side of the boundary or the other. Well, we better name some other points here so we make sure our number line's correct. What number is just to the left of 3? 2. And just to the right is? 4. Okay? Somebody said it'd be an open circle. That's right, because we want numbers bigger than 3. Now, some of you like to look at the direction the arrow's pointing. The problem is sometimes things are written backwards. Okay, Nick? Sometimes things are written backwards, and that's a problem to decide which way to graph it. Uh-oh. Here we go.
Well, just sorry to interrupt. Is Rusty,
No, he's absent.
how about Michael Pettigrew?
Yes, he's right over there. Was that it? Okay.
Yep.
Okay, you guys, I want numbers bigger than 3. You know what? This is so easy, you don't have to do anything. All you do is take 3, and you guys, you look at one side and see if that makes it true, or it's the other side. One side or the other is going to make it true. And like somebody mentioned 4, Maurice mentioned 4, so 4 makes it true. Well, if 4 makes it true, then everything else on this side makes that sentence true. It's a boundary between what's true and what's false. Is that dot really bigger than all the other dots? No. We make it big so we can see it, so we can see where the boundary is. I mean, for many years, I thought it was a bigger dot because we always did that, and nobody ever explained that. So if you do that, you really have nothing else to think about. Just want numbers that make it true. So you take 3 and you test 4. Is 4 bigger than 3? Yes, it is. If I test it with this backwards one, is 3 smaller than 4? Is that true or false? Yes. It's a true or false idea. Even when you divide by negative signs, I don't really have to do that. Whoops. Okay, ready to go to the next page? Because these, oh yes. And these go pretty fast. But if we understand what solve means, then this is pretty easy. Some of you like to put the arrows in and say, well, if it's greater, then it's going to go that way. Well, not if it's backward, it's not. And sometimes you don't recognize if it's backward. So just test points on, you only really need to test one side. You don't have to test both. Okay, ready for me to change now? Okay, so where's our boundary here? 2? What kind of 2? Negative 2. So we'll put negative 2 here. Okay, what's to the left of it? Negative 3. Paris?
Okay, so it's like the numbers that you're looking at always goes in the middle one?
I could put them anywhere. I could have put the negative 2 here, but I need to have numbers on both sides of negative 2. That's negative 1.
Okay.
I could have put them down there too. So I want numbers. What's that going to be? Less than, smaller than, or equal to 2. So I'm going to put a dot at negative 2. Sorry. And I lost the sign there for a second. Do I get to shade it or is it open? Remember, it's got that extra little bit of line underneath, so it's got a little extra pencil mark. So yes, I'm going to shade it in. And then I'm going to test. Any one of those numbers, any number you want, is either going to be one side or it's going to be the other. What number do you want to test?
3.
Negative 3 or 3?
Negative.
Negative 3. It's negative 3 smaller than or equal to negative 2. Is that a true statement?
No.
Yeah. -3 is smaller than -2.
Oh, yeah.
What would be an easier number maybe to test? 0. Is 0 smaller than -2? No, it's not. So I can't shade this side. This is a boundary. The right side will be shaded or the left. We know that -3 is smaller than that, so it goes that way. And that's all there is. Yeah, we're just going to start off with simple problems like this. We may have to do a little bit of some work here. Just trying to see which is, yeah, we have a worksheet. Yep. Ooh, I think we'll do these, not yet. Get through my notes here, because
I did it in my other class.
that's good. We're gonna do it. You'll have plenty of time to get it done. Oh, all you do is put a dot in there and shade one side or the other. Oh, that's not good. Those who are ready, go ahead and go to the next page. You should be drawing. Oh, he's a little behind me too. Oh no, you're ahead of me. Okay, ready? Okay, what do I want? What is this symbol? What is that? Jake, what is that? No, what is that symbol I just pointed to? Greater than. Okay, do we have those down? Greater than or equal. If you translate it into English, I think it helps you. That's an or. Sorry. So where am I going to put my dot? -5. I'm going to put, what kind of a dot? Closed or open? Closed. Which number would you, oh, I got to put some more numbers here. What number is this? -6, -4. Okay, so which side gets shaded? Merdice, do you know? Which one do you want to try? What number would you like? -4. Is -4 bigger than or equal to -5?
Yep.
Yes. So guess what?
Very big.
These are all bigger numbers than the left. What's next? -3, -2, -1, 0. 0 is bigger than a -5. Everything to the right is bigger. Let's write that down. These are bigger. It's just what we've agreed to do. Smaller. So that's true. And you don't have to write any of this down. All you really need is the answer. The closed circle and which side, one side or the other, it will be shaded, graphed, whatever. Yes.
If it has a line underneath, is it a closed circle then whatever way that arrow is pointing?
I don't do it that way because what if I write it this way? -5 is less than or equal to x. It's in the wrong order. Still goes to the right. Yeah, that's the problem. So I'm trying it a little differently because when we divide, when we have negative numbers in here, things are going to be more complicated. But the way I'm doing it, it should be easy. Okay, we ready? Oh. Okay, where's the boundary here? Elias? Elias, you're supposed to be writing this down, not whatever you're doing. Where's the boundary? Okay, you guys, you're going to turn this into me. I'll either paper or on your iPad. So where's the boundary? What number is it going to, where's the place where it changes? At 6. Okay, Paris, what's this one?
Okay, that's 5.
5, 6.
4. No, wait, no, I'm thinking.
Just count. 5, 6. What comes after 6?
7.
7. That's all it is.
Wait, it just adds up.
This is just the number line. 3, 2, 1. Okay. Yeah.
10.
Okay. Now, is it open or closed? Nick, is it open or closed?
Close.
Does it have the extra line? So it doesn't get the extra shading. It's open. The only way it would be closed is if it had that little line there.
So if it has that line, that's what tells you if it's closed or open.
That's right. Because that's the equal to.
So that this will actually be this way for you. So like if it goes like this, and that's open.
Closed. Oh, no, you have the extra line underneath it?
Yeah.
Then it's closed.
And it's closed. And then if it's like.
Because it has a little extra line, so it has a little extra shading. But now the hard part. Which side are we going to shade? What number do you want to try? Alex, you want to try a number? 7. Is 7 smaller than 6? Which is less, the 6 or the 7? The 6 is less. I'd rather have $7 than $6. So 7 does not make it true. So it will go the other direction. And you want to double check? Let's try 5. Is 5 less than 6? Yes, it is. It's one side or the other. That's it. I'm making it easy. And actually, if you know that, you go up into higher level maths, it's easy. Yeah, but we haven't gotten to the hard problems yet. How about that one?
Don't we have to like break down the equation and like,
We will. We haven't gotten there yet. Where's the dividing point here? Where's the boundary? 0. What number's to the right? That's negative 1's to the left. To the right is 1. Okay. I haven't made it yet. I have to do it because I was going to do paper pencil. Okay. X is less than 0. What number do you want to try? Can't try 0 for sure. Negative 1 is negative 1 less than 0. We should all get that because that's when we say it's below 0 here in Minnesota. So I'm going to have an open or closed.
I think it's funny when I go to North Carolina, I'm like, it's 40 degrees of cold. I'm like, no, this is North Carolina.
Yeah, that's right. Is this open or closed at 0? But you get to fill in the circle or not?
Yeah. Oh wait, no, you don't.
No. And we decided negative 1 made that true, so there we go. That's it. That's all there is. It works for every single inequality, no matter what you do to an inequality. X is greater than or equal to 4. Closed, that's right. So there's 4. You're going to close it. Which number do you want to try? 2. Is 2 bigger than 4? No. So guess what? It's going to go the other direction. It's not going to go to the left. It'll go to the right. Is that okay? Elias, you're supposed to be writing these down. Okay. Now it's... Oh, I'm sorry. Let's see how many more we got. Right. That is probably a true statement on that. And these are a lot harder. I don't want to do those yet. We'll do those tomorrow. Okay, ready? Okay, this one's got a little work to do to it. See, we're going to start getting equations, or not equations, but have more to it than that. Can we simplify that? X is less than or equal to what number? 3. Okay, so where's my boundary point? Positive 3, 2, and 4. Always label at least 3 numbers. Is it 3? Is that open or closed, Jake? Closed. And I want numbers smaller. Yes.
Wait, so you would add them to an alignment?
Because I can. That's right. Okay. And so what works here? What do you want to try? 2? Is 2 smaller than 3? Yes. So that's how it gets shaded. This should be easy. You should easily finish this worksheet. And these are some word problems. I'm going to hold off on those. What if, because I want to get you into the worksheet I have, but what if we have minus x is less than 3? I'm going to have to solve for that. Thank you. I'm going to have to solve for x. What do we have to do if we have a minus there? It's times, though. It's negative 1 times that. Remember how to solve those? Or maybe, well, let's do this one. Negative 2x is less than 4. There, maybe that's easier. Now what do we do?
You will plus.
No, not plus. What's the opposite of multiplying? Divide by what? Negative 2. You want a positive x there. You don't want a negative. Now, I don't know if you remember, but when you divide by a negative number, the inequality sign reverses. So this is going to switch to greater than negative 2. But I don't have to remember that. If I do this, I pretend, because this works every time, that I have negative 2x equals 4. I got to find my boundary point, so I do have to do a little work. I'll divide by a negative 2, and then x is equal to negative 2. So that's my boundary point. And here's negative 2. I need a number to the right, which would be negative 1, a number to the left. You can, you should, because you're gonna run into some on the worksheet. Now, I want numbers. My negative 2, is that going to be open or closed? Open or closed? Open. Now, the problem is sometimes you forget to reverse that inequality. So if I go up here, I found my boundary point, and I just test any old number you want. What number would you like to test there? See which way this thing's going to go. Because I forgot that if I divide by a negative, the inequality reverses. It's the only time you ever have to worry about it is when you multiply or divide by a negative. But we don't even have to worry about it. What number would you like to try, Paris?
Please pick
Any number.
negative 1.
Negative 1. So this says, sorry, wrong inequality. Negative 2 times negative 1, how does that compare to 4? What's the negative 2 times negative 1? No, 2 negatives make a. How does 2 compare to 4?
If you add 2 plus 2.
Is that smaller? Yeah. So did negative 1 make this statement true? Yeah. Now I know that if I divide by a negative sign, I reverse the inequality. And that's what this says. X is bigger than negative 2. But you don't have to do that. You honestly don't have to worry about that. So these are fairly simple ones. You have some with negatives. Let's do one that's backwards, because sometimes we get them backwards. So I have negative 5 is greater than x. Where's the boundary point?
Negative 5.
Let's make it equal to. It was negative 5. And am I going to close it or leave it open?
You're going to close it.
Close it. Good. Okay. Now, Nick, I don't know which side to shade, because it's written backwards. So let's get some more numbers here. This is negative what? 4. Good. Then this is negative 6. What number would you like to try, Nick? Any number you want. Negative 4 or positive 4? Positive 4, okay? Is negative 5 greater than or equal to a positive 4? Is that bigger than 4? No. So guess what? Are we going to shade to the side where there is a positive 4, Michael, or we shade to the other side?
Shade to the
Other side. I don't have to worry about this. So see, this little arrow does not point in the right direction if it's not written the right way. The other thing you can do is you could take this. It's going to look weird. And basically, I want the inequality, I want the x on the left side, so I'm going to do this. I'm going to flip that left, right. And now the arrow does point in the correct direction, Jake. When I flipped it. My negative 5 is reversed, but that's okay. No big deal. You want me to flip it back? I know, it looks weird.
Wait, so
That's the way I gave it to you. This arrow does not always point in the direction to shade. Mm-mm. In this case, it doesn't. It shades the other way. So you have to be careful. If you want to use that little trick of the point pointing in the right direction, it's only true when, and I'll clone this, when, oops, I didn't need to make it bigger, when the x is on the left. So if I flip this, and I put the x there and the negative 5 here, what happens to the inequality? It flips as well, doesn't it? But that's hard. It's just a lot easier. What if I have 2 is less than or equal to x? Or I can think about it. What numbers make that true? Where's my boundary? 2. Number to the right? No, Jake, we're not doing that. Number to the right is 3, and number to the left is?
-1. Oh, no, 0.
Right to the left of is 1. Okay, so now at 2, we're going to put what kind of circle?
Open.
Has a little extra closed. If it has extra little line. Now, I don't know which way to shade. If I want to flip it, I can. But if I don't want to flip it, I'm not going to. What number do you want to try?
I'll try 3, but can I ask something real quick?
Yes, please.
Okay, so when you go, like, so the line underneath, like the alligator mouth, that always tells you if it's closed?
Yes.
Okay, because I thought the alligator mouth, if I was going in that direction after it opened the alligator.
No, it's the little line underneath that means equal to. Okay, Chelsea, do you want to pick a number? Any 1. So you're going to see if 1 makes it true. So you have to think a little bit, but 2, is that less than or equal to 1? Is 2 smaller than 1? No. Yeah, you're right. You have a 50-50 chance. Okay, that is false, right? So I'm not going to shade the side with the 1. I'm going to shade the other side. If you want to try another number, just to make sure, like 3, is 2 less than or equal to 3? Is 2 smaller than 3? Yeah, that's true. So I did shade the right side. It's one side or the other. Once you find the boundary point. Okay, so we're going to, we have a worksheet.